Videos I have discussed about calendar problems, clock problem and series formation. So today I am going to explain you about numbers. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos like this. So let us discuss numbers. In our day-to-day life, we use decimal systems comprising 10 numbers, as we know, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these all are what we call numbers. So number in mathematical form, we use them for counting and measuring. So if you want to count any of the thing, or if you want to measure any, if you want to make any measurements, you require numbers. So group of these digits called numerals. Various types of numbers are there. First, natural number, counting numbers called natural numbers. So you can just count them like 1 to 9 and so on. Not only up to 9, these all are what numbers, but you can start with 1, 2, 3, 4, but it is not included here, it is not included 0, natural numbers. So natural number starts from 1, 2, 3, 4 and so on. So whole numbers, all counting numbers including 0, we call together as whole numbers. So 0, 1, 2, 3, 4 and so on. Integers, all counting numbers including 0 and negative of counting numbers for integers. So however, it includes natural number, whole number, but negative numbers also. So such numbers we call integers, like 0, 1, 2, 3, minus 1, minus 2, minus 3 and so on. Even numbers, integers divisible by 2. Even numbers are divisible by 2, whether it may be negative numbers or positive numbers. So 0 plus or minus 2 plus or minus 4 or plus or minus 6. Odd numbers, integers not divisible by 2, like 1, 3, 4, sorry 1, 3, 5, 7, 11, 13, like that, whether they may be positive or negative numbers. Integers means including 0, negative and positive numbers, so which are not divisible by 2. Prime numbers, a number divisible by itself, and 1. If you take 2, however, it is even number, but it is only divisible by 1 and itself. So like 3, 5, 7, 11, 13 and so on. Composite numbers, natural numbers which are not prime, called composite numbers. Means they are like they are neither prime nor one. If you take 1 here, it is not included. 1 is neither prime nor composite number. So prime numbers are divisible by itself or 1. So the numbers which are not prime number we call composite numbers, like 4, 6, 8, 9, 10, 12. They are divisible by any of the numbers. Perfect number. So as the name indicates, these numbers are formed which when you add up all the factors less than that number. So let us take one example. 16, if you take, it is having the factors, or it is divisible by 1, 2, 4, 8. If you add all these numbers, 8 plus 4, 12, 12 plus 2, 14, 1. So 15 you will get when you add, but it is less than 16, so it is not perfect number. So 28, if you take factors of 28, 1, 2, 4, 7, 14. If you add all these numbers, 14 plus 7, 21, 25, 27, 28. So this is what the perfect number. Perfect square, which is written as product of two equal factors like 36, 49, 64, they never end with perfect squares, never end with 2, 3, 7, 8. If you take above examples, they are ending with 6, 9, 4, but they never end with 2, 3, 7, 8. So 36 is the square of 6, 6 into 6. This is square of 7, 49, square of 8. So these all are what? Perfect square whose written as the product of two equal factors like 6 into 6, 7 into 7, 8 into 8, like that. But they never end with 2, 3, 7, 8. Divisible by divisibility of number. So which numbers are divisible by 2? In some questions, big number if they have given, at that time you should know this divisibility rule for all the digits, then only you can easily solve that. So divisible by 2, if the number is ending with 0, 2, 4, 6, 8, last digit of the number, then they are divisible by 2. Divisible by 3, sum of its number divisible by 3. If you have given any of the problem like let us take 343. So sum of its number, if it is divisible by 3, then it is, we can say it is divisible by 5. So 4 actually I should write here. If its last digit is 0 or 5, then that number is always divisible by 5. So for 6, if it is divisible by 2 and 3, then that number is divisible by 6. So 7, subtract twice the unit digit from the number represented by the remaining digit of the number to obtain the integer. So if you want to get the divisibility of 7, you have to subtract the twice the unit digit from the number represented by the remaining digit of the number. So with the example you can understand. By 8, if the number found by the last 3 digits are divisible, then it is divisible by 8. By 9, if sum of the digit is divisible by 9, then 10 divisible by 10 ends with 0. By 11, a number is divisible by 11 if the difference of the sum of the digits in the even and odd positions in the number is either 0 or divisible by 11. So these are the divisibility rules you can follow for getting the solution for the given problem. So GCD and LCM, greatest common divisor and least common multiplier. So factors and multipliers we come across to understand GCD and LCM. Express each one of the given numbers as the product of prime factors. The product of least power of common prime factors gives GCD. Prime numbers are what? They are divisible by 1 and itself. So here let us take one example, 504. If you take the factors of 504 are given here. So it will be 2 cube, 3 square and 7 to the power 1. 264, 2 cube, 3 to the power 1, 11 to the power 1. So common factor is here 2 to the power 3 and 3 to the power 1. So it is equal to 24. So this is what the greatest common divisor, DCD, of a given number. Least common multiplier. So smallest number which is exactly divisible by each one of the given numbers. So express each one of the given number which is exactly divisible by each one of the given number as product of prime factors. And here you should note down the product of highest power of all the power all the prime factor gives LCM. So LCM is quite opposite to GCD. Here the product of least power of common prime factors. Here product of highest power of all the prime factors. So let us take same example here. 504. These are what factors, power of the factors, and 264 to power of the factors. From both, here which one are the common here? 2 to the power cube, 3 to the power 2, 7 to the power 1. So here 11 to the power. All the prime factors we have to take product of them. Highest power of all the prime factors. Then if you multiply, you will get the LCM. So some points you should remember here. Product of two numbers. If you take a product of any two numbers directly, if you want to calculate, if you know the product of GCD and LCM, you can solve. So product of GCD into LCM nothing but the product of two numbers. GCD of a given factor. It is ratio of what? GCD of numerator to the LCM of denominator. LCM formula for a given factor. LCM of numerator to the GCD of a denominator. If the number is in the form of fraction, then you can solve like this. BODMAS. This you know since school days. So bracket of division, multiplication, addition and subtraction. So you can solve for the given problem. First you should solve bracket in the order. Round bracket, flower bracket, square bracket. Okay. So operations you should follow. Division you have to do first, next multiplication, next addition and subtraction. If the problem has been given, you should first solve the bracket like this in the order, and operations also you should solve like this: division, multiplication, addition, subtraction. So modulus of real number, if you take any of the number, you come across modulus in positive value, positive or negative number. Quadratic equation, you can write the quadratic equation like this: ax square plus bx plus c. A, B, C are real numbers where a is not equal to 0. F of x is equal to 0, then we can find out the roots. So here d discriminant we can write it as d is equal to b square minus 4ac. Sum of the roots is given by alpha plus beta, that is minus b by a. Product of roots alpha into beta, c by a. Alpha and beta are nothing but roots. So here we can also represent the quadratic equation in the form x square sum of roots into x product of roots is equal to 0. Let us take alpha and beta, roots 3 and 5. Then you can find the quadratic equation, or else you can find the roots from the given equation, vice versa. Fraction. A fraction represents a part of whole or a more generally any number of equal parts. So fraction is nothing but a part of the whole or more generally any number of equal parts. If you take any of the material, if you divide into equal parts, then you can write in terms of ratio. So like you have different types: proper fraction, numerator less than denominator. You can see the example 1 by 4, 2 by 5 like that. Improper fraction whose numerator equal or greater than the denominator. So here are the example. So 14 by 13, 20 by 7, numerator is greater here, denominator is smaller in number. Mixed fraction, whole number and a proper fraction. proper fraction numerator is greater than denominator. So mixed number we can take the whole numbers like 8, 1 to 0 to 9. 8 is to 1 by 2. So these are example for mixed fraction. Laws of exponent, nothing but power. A by b to the power m, how you write? A to the power m by b to the power m. So a to the power 0 is equal to 1. A to the power minus m, 1 by a to the power m. These small rules you should know. This is nothing but root of m. So this is product of a to the power m and n. You can write a to the power m plus n. So this one ratio of a to the power m by n, a to the power m minus n. A to the power m into n you can represent, or else ab to the power m, a to the power m, b to the power m. So if the number has been given and their powers also they have given, if the same number having different powers, then the order of power you must take. Then you can identify the biggest number or smallest number. If powers are same, like a to the power x, b to the power x, c to the power x, then you can select the biggest number here. So like that you have to solve. Algebraic equations already you know. So all these are related to what? Mathematical expressions, whatever you have studied already in school or PUs. So this will be helpful to solve further problems. A plus b whole square, a minus b whole square, a plus b cube. All these equations you should practice. Power last digit. If you take any of the last digit of power, how you can identify? If the last digit is, let us take from 0 to 9. Okay, decimal numbers. So power cycle, how it is going to repeat? If you take the last digit is 0, the frequency power cycle is 0. That is 1. Frequency is 1. If you take the last digit of the power is 1, that is 1. And 2, if the last digit of the power is 2, then you may come across 2, 4, 8, 6. Their frequency is 4 for last digit which is 2. It may be divisible by 2, 4 or 8 and 6. So you have to verify all the 4 numbers. So for 3, the number ending with 3, you may come across again 4 numbers. 3, it may be divisible by 3, 9, 7, 1. So frequency is 4 for number 3. Last digit 4, you will come across it may be divisible by 4 or 6. Power may be 4 or 6. So 2 frequency. For 5, only 1 5 number will come. 6 also 6. 7, you have again 4 numbers here. It may be divisible by 7, 9, 3, 1. Frequency is 4. 8, 8, 4, 2, 6. The frequency is 4. For 9, it may be ending with 9 or 1. So 2. So this table you must practice here. Usually 2, 3, 7, 8 have the frequency of 4. And 4 and 9 have the frequency of 2. 5, 6, 1, 0 have the frequency of 1. Important sequences. So especially some of the questions will be asked from arithmetic and geometric sequence. Arithmetic sequence, each term differ from its preceding term. So the nth term, if you want to find out, this is the equation for arithmetic sequence. Tn equal to a plus n minus d. A is what the difference first term and d is the difference, common difference. So sum of nth term, if you want to calculate, this is the standard formula, n by 2 to a plus n minus 1 into d. So these important formulas you should remember for a given problem. Sum of the first n consecutive natural numbers, n into n plus 1 by 2. Directly you can use this formula. If the sum of first n consecutive numbers they have asked. So sum of first n consecutive square numbers, that is n into n plus 1 into 2n plus 1 by 2. Sum of n consecutive cubic numbers. So that is given by n square into n plus 1 by 4. Geometric sequence, every term having a constant ratio with its preceding term. So this is the equation for to find nth term. Tn is equal to a into r to the power n minus 1. Nth term, sum of the nth term is given by a into r to the power n minus 1 by r minus 1. So r is greater than 1. Infinite geometric progression, this is the equation. A by 1 minus r. So these all are related to the numbers. So I hope this is helpful for you to solve the problems related to numbers. So this is the theory first you need to understand, then you can solve. In the next video I am going to solve the problem